Hello, my dear students. I am Dr. Dharmendra Tyagi, Associate Professor, Mechanical Engineering Department, SIRT, the SAGE Group, Bhopal. Today, we are going to discuss about the analytical method for angular velocity and angular acceleration of the connecting rod. So today we are going to discuss about this. So here you can see this is the slider crank mechanism. As we have already discussed in the previous video lecture. We have already calculated the velocity of the piston. What is this? R omega sine theta plus sine 2 theta upon 2n. So this is already calculated in the previous video lecture. So in this video lecture, we have to calculate or we have to derive an expression for the angular velocity and angular acceleration of the connecting rod. So velocity of the piston and angular velocity of the piston and acceleration of the piston we have derived in the previous video. The value, the formula of these are displayed on your screen. That is Vp, that is equals to r omega sine theta plus sine 2 theta upon 2n, and AP, that is acceleration of the piston, that is equals to r omega square cos theta plus cos 2 theta upon n. Now, in this video lecture, we will discuss about the angular velocity of the connecting rod, and after this, angular acceleration of the connecting rod. So first of all, we will start from the angular velocity of the connecting rod. Here we consider the motion of a connecting rod and crank as shown in this figure. Here you can see this is the length of the crank and this is length of the connecting rod, and this is the position of the piston at point P, and the movement of the piston from P to P dash, that is represented by X, which is the displacement of the piston we have already discussed. But the angular velocity of the connecting rod, this is connecting rod. The angular velocity and angular acceleration of the connecting rod, we have to derive the expression for this. And this is the phi, this is the angle of the connecting rod with IDC or line of stroke. And this is the angle theta, or we can say that the angle theta is known as crank angle. And now, from the geometry of the figure, we find that the value of CQ, this is the C and Q. This is the CQ. The value of the CQ, that is equals to L sine phi. L sine phi. L is the hypotenuse, or CQ is the perpendicular. The perpendicular upon hypotenuse, the value of the perpendicular is equals to hypotenuse into sine phi. The L sine phi. Similarly, in this right angle triangle, here you can see the value of CQ, that is equals to, in this case, the hypotenuse is R, and this is the OQ. This is OQ. What is this? This is the base, and this is perpendicular, that is CQ, which is perpendicular, and apply the formula, same formula, perpendicular upon hypotenuse, that is sine theta. So perpendicular upon hypotenuse, that means we have to calculate the value of perpendicular, that is CQ. The perpendicular is equals to hypotenuse into sine theta. So here you can see the value of CQ, L sine phi is equals to R sine theta. Now from this equation, we can also written here like this: L upon R is equals to sine theta upon sine phi. L upon R, that is equals to N. That means the length, it is the ratio of length of the connecting rod to the crank radius, which is represented by small n. That is equals to sine theta upon sine n. So, we can also write it here, the sine phi, that is equals to sine theta upon n. So this is the formula. We can use this formula further. Now, the differentiating both the side with respect to time. This equation, we can differentiate this equation, and we will have the value of sine phi, differentiation of the sine phi, that is equals to cos phi and d phi upon dt, that is equals to the differentiation of sine theta, that is equals to cos theta, and n is the constant, and this is d theta upon dt. The d theta upon dt, we can here the theta is the angular displacement of the crank. So this is omega, the theta upon t, that means angular displacement upon time. So that is omega, angular velocity. So here you can see this is represented by omega. And now, since the angular velocity of the connecting rod, this is PC, is same as the angular base velocity of the point P with respect to this point C, and is equals to d phi upon dt. So therefore, the angular velocity of the connecting rod, which is represented by omega C, that is equals to d phi upon dt. So substitute the value of d phi upon dt from the previous equation, and we have the omega C, that is equals to cos theta upon n into omega upon cos phi. Or we can write it here. This is the separate out omega upon n and cos theta upon sin phi. Now, as we know that the sin square phi plus cos square phi, that is equals to 1. And it can also be written like this: sin phi is equals to 1 minus k sin square phi and raised to power 1 by 2. We have derived the value of cos phi previously in the previous video lecture, and the value of cos phi, that is equals to 1 minus sin square theta upon n square raised to power 1 by 2. Substitute this value in the equation, in the above equation, that is omega C is equals to omega upon n into sin theta upon sin phi. And then we have the value of omega C, that is the angular velocity of the connecting rod, omega upon n into cos theta divided by 1 minus k sin square theta upon n square raised to power 1 by 2. By solving this equation, we will have the value of omega C is equals to, this is the same, and only the solving this equation by taking the LCM, and n is 1 upon n square minus sin square theta raised to power 1 by 2. And the final value of omega C, that is equals to omega cos theta divided by n square minus sin square theta raised to power 1 by 2. So this is the simple derivation of angular velocity of the connecting rod. So now the angular acceleration of the connecting rod. So now we have to calculate the angular acceleration of the connecting rod, derive the expression for the angular acceleration of the connecting rod. So as we know that we have the angular velocity. So now the differentiation with respect to time of angular velocity will give the angular acceleration of the connecting rod. So here the angular acceleration is represented by alpha c. So that is the alpha c, that is equals to d upon dt into omega c. So substitute the value of the omega c, that is angular velocity of the connecting rod, in this equation. And then we have the value of alpha c is changed. And what is the value of alpha c? Here you can see the d omega c upon dt, that is equals to d omega c upon d theta into d theta upon dt. And the d theta into d theta both are cancelled out, and this is the same equation as we know that. And the d theta upon dt, that is equals to angular velocity. So substitute the value of angular velocity in terms of d theta upon dtt, that is the omega. And here d omega c upon d theta, that is equals to, you can see here the now differentiating the equation number 1, and we get d omega c upon d theta, that is equals to d upon d theta, and omega upon cos theta upon n square minus k sin square theta raised to power 1 by 2. This is the value of angular velocity of the connecting rod. And here you can see the after the differentiation of this terms, and we will have the values minus k omega sin theta n square minus k 1 divided by n square minus sin square theta raised to power 3 by 2. So now the value of alpha c, angular acceleration of the connecting rod, that is d omega c upon d theta into omega. So substitute the value of d omega c upon d theta from the above equation, and we will have the value of angular acceleration of the connecting rod. This is the angular acceleration of the connecting rod, minus omega sin theta into n square minus 1 divided by n square minus k sine square theta into 3 by 2 into omega. So this omega into omega, that is omega square, and the final value of alpha c, that is angular acceleration of the connecting rod, is minus k omega square sine theta n square minus 1 divided by n square minus sine square theta raised to power 3 by 2. Now this negative sign. So what is why this negative sign comes? The negative sign shows that the sense of acceleration of the connecting rod is such that it tends to reduce the angle phi. This is the angle phi. So this is all about the velocity and acceleration of the connecting rod. So this is the angular velocity and angular acceleration of the connecting rod. In this video, before watching this video, we have to watch the previous video related to the angular velocity and acceleration of the piston. So thank you.